kitchen is a bit like a science lab. Understanding the science of cooking helps you make food taste as it should. So why does food behave as it does when we cook it? And what's going on in our head when we eat it? Jellies. In this episode, enter a strange new world with an old friend or two. I'm going to show you why a chip is just like blackcurrant jelly and how to use these jellies to make exciting new flavour combinations. Plus, learn how to make the best bangers and mash on earth. First, what exactly are jellies and gels? Now, this one down here is we should all know. Almost the ultimate, the most famous childhood dessert of all. It makes this. The lovely wibbly wobbly jellies and cream. Now, these effectively are made with gelatine. Gelatine is extracted from meat and bones, basically by just boiling them up. Now, if you've ever made chicken soup or oxtail stew, you'll know after prolonged cooking and maybe reducing the liquid down a bit, you end up with a really sticky sauce. When it's cold, it actually sets it. It becomes a jelly. This is exactly what we use to set these. Gelatine is the original gelling agent and is still one of the commonest. Here's a sweet jelly we serve at the restaurant. It's made of beetroot but tastes of blackcurrant. You can make some savoury jellies like this one made from quail meat without adding any gelatine. It produces its own, the same sort of jelly as you get in meat pies. This is a sheet of jellied passion fruit juice. It's not made with gelatine, but with an unusual gelling agent extracted from seaweed. Gel is just the scientific word for jellies. You can gelatinize food using other agents apart from gelatine. This is chocolate jelly. We've made this using a powerful gelling agent, gellan gum, from a plant extract that withstands high temperatures without melting. And this is a jellied tea. Like all gels, it's just a state of matter where a small amount of solid contains a large amount of liquid in a solid-like form. Finally, we have what I think is the cleverest of all of the jellies we have here. This is a pineapple jelly. Now, you cannot set pineapple juice or fresh pineapple juice with gelatine. Pineapple contains an enzyme, a biological catalyst that effectively eats the protein, which stops it from setting. As we saw earlier, the gelatine itself is extracted from meat and bones, or effectively protein. There's a very simple way to demonstrate the power of this enzyme at home. Take a piece of pineapple, like this, and basically just cut a piece, not too big, but just enough so you can fit it underneath your top lip. Excuse the slurping noises. Okay, now you need to leave this under your lip for 5 to 10 minutes. And what will start to happen is you'll get this very mild throbbing sensation, which will then become stronger. And now my gums are now starting to throb. And it's actually becoming a little bit uncomfortable. The enzyme is so ferocious, it immediately starts attacking the proteins in your gums, which soon get very uncomfortable. It would attack gelatine in just the same way. That's it. It's now throbbing quite strongly. Oh. Once you've done that, you really can see how it's very difficult for a sheet of gelatine, which effectively is protein, to set the juice made from a pineapple. So I'm going to show you a technique which I discovered a couple of years ago. And effectively, by using this, we can make our pineapple jelly. First, take some fresh pineapple juice and pour into a pan. Meanwhile, take some sheets of gelatine that we saw earlier and soften them in cold water. Gently heat the pineapple juice and add to it 1 chopped capsicum, red chilli, seeds as well. This is the magic ingredient, as it contains a chemical that destroys the enzyme in the pineapple, allowing you to make the jelly. When the pineapple juice is warm to hot, gently remove the gelatin leaves from the water. They should now be very soft. Squeeze the excess water off the leaves and carefully add to the pineapple juice. Now simply stir the pan until the gelatin is dissolved into the pineapple juice. Pass through a fine sieve into a bowl or mould of your choice and store in the fridge until set. This should take 2 to 4 hours. And then serve. Simple. So what's happening at the molecular level when we make gels like these? A gel's a network of long molecules, partially dissolved in liquid. Present in all jellies, this helps trap moisture in food as we cook it. And with the moisture, we store the flavour. All food's made of cells. Inside the cell walls, moisture, and inside that, molecules containing flavour. When we chop or cook food, we break down the cell walls. Flavour molecules are released, very light and very volatile. Flying up the nose, they send electrical signals to our brain, which then tells us we're experiencing aromas. Together with signals from the taste in the mouth, these make the flavour. A perfect way of locking flavour into food till we eat it is gels. Gels are everywhere. Marmalade's another gel. And once you add milk, so are cornflakes. And once you add hot water, so is spaghetti, which works as a gel by releasing not gelatin, but starch, just like rice or potatoes. Potatoes are full of starch, one of the commonest carbohydrates found in nature. Swollen with liquid, starch is a superb gel. Know the chemistry of starch gels and you'll revolutionise how you cook potatoes. Inside this potato are thousands of tiny starch granules. Now, our bodies aren't designed to digest these starch granules in the form that they're made by the plants, so we have to cook them, and we have to cook them in the right way. And here, I've got a potato that I've pre-soaked at 62 degrees. And under normal circumstances, a slice of potato, you wouldn't be able to see the starch granules. But by this pre-cooking method or pre-soaking method, we can see them. So hopefully I'm going to cut a thin slice off of this potato and show you. And here we are, we can clearly see all the small granules of starch, some bigger than others, but there's loads of them in this slice of potato. And what's happened is the granules themselves have been swollen with water. Now when we cut through the granules, the water leaks out. Let's have a look here. We can see some moisture on the surface of the potato. It might not look a lot, but believe me, the dams are bursting. As you cut, the walls of each granule burst and the starch escapes on its way to forming a gel. Each one of these starch granules is a mini jelly. And the key to cooking potatoes, whatever their usage, is keep the gels and the starches on your side. I'm going to show you how to make the greatest chips on earth. That is a sweeping statement, I know, but they really are sensational. Although we're using a couple of clever pieces of equipment here, you can follow a method at home that will revolutionise the way you make your chips. This is a desiccator, a fancy demoisturiser. After first cooking chips in water, we put them inside. It's connected to a pump which creates a vacuum and sucks the excess moisture out of the chip. You won't find this piece of equipment in a kitchen shop. It's actually a piece of scientific laboratory equipment. So you're probably thinking, well, how on earth am I going to get hold of a desiccator? Well, don't worry, all is not lost. The secret to making good chips at home is 3 cooking processes. Simmer the chips, cool them. Cook them in warm oil, cool them. Cook them in very hot oil, serve them. Simple as that. After boiling and cooling, you then fry them in warm oil, around 130 Celsius. So what we're doing now is there's been some starch built up on the surface of the chip after being cooked in simmering water. This now is being gelatinised on the surface during this cooking process, which will ultimately provide our crisp, really crunchy exterior. Then, after cooling again, fry them in hot oil around 190 Celsius. There you are, top-notch chicken and chips. Coming up, how to use the chemistry of gels to make the best mash in the world.